Welcome to the video on problems based on transient analysis of RL circuits. So first let us see a problem here. In the RL circuit shown below, the switch is closed at t equal to 0. Find the current I of t and the voltage across resistance and inductance. So three things have been asked to find out. One is I of t current which is flowing inside the loop, and the voltage across the resistance as well as the inductance we need to find. So this is the circuit which is given, which has got a 10 volt battery, and the switch is open at the initial condition and closed at t equal to 0, and the resistance is given as 5 ohms and the inductance is given as 0.5 Henry. Now whenever you start with a solution, you have to consider the initial condition. So at t equal to 0 minus, that is I of 0 minus, that is when the switch is open, there will not be any current flow, so we can write it as 0 amps. When the switch is closed at t equal to 0, it becomes a closed circuit. Then you'll have this I of t, that is the current will flow inside the loop. So this current can be found out by applying KVL to this loop. That is 10 u of t. Of course, the 10 volt has to be represented as 10 u of t, which is equal to 5 into I of t plus 0.5 di of t by dt. So this is the KVL. We need to apply Laplace transform for this equation. We know for the u of t the Laplace transform is 1 by s, for I of t the Laplace transform is I of s, and for di of t by dt it's s I of s minus I into 0 minus. We know already this is going to be 0 amps. So once you substitute that, and after a small rearrangement, we get I of s is equal to, it's going to be 20 divided by s into s plus 10. So by using the partial fraction method, we could separate it as a by s plus b by s plus 10. From this, you can easily get, when you take the value s equal to 0, you get the answer of a as 2, and if you take s is equal to minus 10, the b answer you will get it as minus 2. So once if you substitute here, this is going to be I of s. Now the last step is taking inverse Laplace transform. So when you take inverse Laplace transform for this, definitely you get I of t is equal to 2 minus 2 into e power minus 10 into t. So we know 1 by s is just, if you take inverse Laplace transform, it's just 1. So for s plus 10, it's going to be e power minus 10 into t. So if you take 2 commonly outside, the final answer you get here as I of t is equal to 1 minus e power minus t by 0.1. Okay. So we can easily get the VR of t also as I of t into R. So we know the R resistance is 5, and we know what is I of t. Just substitute, you get VR of t is equal to 10 into 1 minus e power minus t divided by 0.1. Similarly for VL of t, you could write the equation as L into di of t by dt. So whenever inductance comes, it's di of t by dt. So once if you substitute this I of t here and differentiate, you get the final expression of VL of t as 10 into e power minus t by 0.1. So this is the problem 1. We have found out I of t, VR of t and VL of t. Next we'll see an important problem based on this RL circuit itself. So in the RL circuit shown below, the switch is closed at position 1 for a long time and then thrown to position 2 at time t equal to 0. Determine the response I of t. So they are asking you to find the response I of t, and they are giving you 2 different conditions. So when you look at the circuit itself, you could understand there are 2 positions of switch. So initially it is at 1, and after some time it is moving over to t equal to 0. At that point it is moving on to switch position 2. So we have got 2 batteries here, 50 volt which is minus plus, and 50 volt here as plus minus. So you have got a resistance 5 ohms and an inductance 2 Henry. So whenever you start with a solution, start with case 1 when the switch is at position 1. So if switch remains closed at position 1 for a long time, then the circuit might have attained the steady state. So that initial condition steady state, this definitely the inductance will be acting as on a short circuit, and you will get the loop like this. Okay, so for this loop, if you start applying KVL, or you can even get this inside current, you can take in this direction because battery is minus plus here. So you get that I naught to be as 50 by 5, which is nothing but 10 amps. Now that is going to be at position 1, right? So next case 2, it's switch at position 2. Whenever it moves to the position 2, definitely the switch when moving from position 1 to position 2, initial current I0 flows through the inductance. So this initial current I0 will be flowing across the inductance now. So I of 0 minus, which is equal to I of 0 plus, which is equal to minus of I0, which is nothing but minus 10 amps. So the direction is of I0 is opposite to I of t. Okay. So this loop, if you start applying KVL, you get this equation. And the next step, what you have to do, you have to apply the Laplace transform. Just apply the Laplace transform, and in the place of I of 0 minus, wherever you get, you just put I0. Then you know the value, it's going to be 10 there. You substitute everything. Then by small rearrangement, you get it as 50 minus 20s by s. So after getting this equation, if you do partial fraction method, a small denominator, they're making some rearrangement here. So the final expression is 25 minus 10s divided by s into s plus 2.5. For this, partial fraction method is applied. So by applying s equal to minus 2.5, you get b answer as minus 20. And by taking s equal to 0, you get the a answer to be as 10. So just substitute whatever you get, a and b. You get I of s as 10 by s minus 20, s plus 2.5. Now taking inverse Laplace transform, you get I of t to be as 10 minus 20 e power minus 2.5 into t. So from this you get tau is equal to 1 by 2.5, 0.4 seconds. So just apply that. Over here you get now the equation. Final equation of I of t is 10 into 1 minus 2 into e power minus t by 0.4. So at t equal to 0, I of t is just minus 10 amps, and t equal to infinity, I of t is just plus 10 amps. So we get the response like this. So this is the solution for problem number 2. I hope by watching this video you have understood the problems based on RL circuits. Thanks for watching.